There's so many cameras.
Yeah, there's like 5. Okay,
Hey everybody, and welcome to another Desk of Lady Ada. I'm here at my desk, and I'm Lady Ada. And it's a late night here at the Adafruit Lady Ada household, but never one to stop from hacking. We're gonna do a little bit of hacking tonight. Tonight's project is, I got some prototype PCBs in, and last week I did a tutorial on adding audio to the Pi Zero, which is the new Raspberry Pi, which doesn't have audio jack, and so you can basically reroute the PWM audio signal from pins 40 to 45 to pins that are exposed on the GPIO, and then do a simple RC filter on those pins to get audio out. And it actually works pretty fine. You can get analog audio. It's PWM audio, but it's just fine for most projects. If you're building something that wants to beep or tweet or speak or whatever, it's totally okay, and we connect it up to a headphone jack. But I was thinking, well, this is a good opportunity for me to learn something I don't know about, which is i2s audio. So the Raspberry Pi has digital audio output. It has 3 audio output methods. It has the analog audio output using the PWM method, which is kind of like a little noisy and fuzzy, but works fairly well and is like really cheap. It has audio over HDMI. So if you connect an HDMI cable to a monitor or a TV with speakers in it, it'll grab audio from that. So that's like very high quality audio because it's digital. And then there's a third method that's available on the Raspberry Pi A+, B+, and Pi 2 and Pi 0, which is i2s, which sounds like I2C, I2C, but it's different. It's sound, not communication. And I've never used it before. Like, I've never really had to do digital audio, but it's kind of the standard for digital audio, and I thought, let's try to first enable it on the Pi, and then K-Town and I, and actually Tony Nicola found this chip, so thanks to Tony, and then K-Town and I were like, okay, this is definitely the chip to use. We made a little breakout for it. It's the Max 98357 i2s amp, and what's cool about this chip is, compared to like a lot of people have made like DAC hats or DAC shields, like we carry a couple in the Adafruit shop, and they give you RCA or headphone out. But what's neat about the Max 98357 is it gives you 3-watt speaker out. It actually is a digital direct to a Class D speaker. So if you just want to connect up some speakers, and I grabbed a couple here, like a little speaker like this, you wire it up directly and you get audio. So let's go to the computer and let's get rocking. Okay, so this is the chip, PCM input Class D audio power amplifier, and you can run off of 2 to 5 volts, which is great because we have 5-volt power and 3.3 volt signal coming out of the Pi. It can do 3 watts into 4 ohms, which is awesome at 5 volts. That's like a lot of power. Of course, it isn't too bad. No M clock required, so the Raspberry Pi does not have the M clock pin available. So that's something to be aware of. It's a single channel amplifier, so you can do left or left plus right divided by 2. So you can get the average of the two. On this board, I think I set the default with a resistor to be the average of left and right. But if I was going to, I could also make a dual breakout with left and right. And then they made it so if you set one resistor on one side and one resistor on the other side, 2 chips, it gives you 2 left and right stereo. It's clearly designed to be put into portable cell phone type stuff. This is GSM. It's small. It's available in WLP, which I'm not into, but it is available in TQFN, which I like. So it's a leadless package, easy to pick in place. And here you go. PCM goes in. So this is digital audio in, and then there's the DAC, and you've got the little logic to select left or right channel. There's also some gain control, Class D, and then speaker. So I have the A version, and the A version is i2s audio. The B version does left justified, which I guess, again, I'm totally new to this, but it sounds like it's just a version that instead of having the audio right justified, has it left justified, because you have like maybe 24-bit audio, but the output could be only 16 bits or something, so depending on where the bits are. I did read over this before, but it's pretty straightforward. You basically, this is how I2S works. You've got the, this B clock, left, right clock, left or right, up and down tells you which channel you're listening to, left or right. It seems like I2S only supports 2 channels, really. There seems like there's another version. This is time divided multiplexing, but that's not what we're using. And then the data comes in and just on the B clock, it just flips around, and you get bits going in, and then it swaps over. And I guess M clock would be like a master clock. It doesn't seem to be necessary because it's got this B clock instead. Okay, so what we want to do, and then there's stats on it and stuff. And then I have the breakout. So this is actually kind of nice because you can just see the design. You've got shutdown and mode, and this resistor here sets what kind of channel you want. Left, you would have this R1 be 0 ohms. Right, you set it to 370K, and then if you want it to be a mix, you do 1 mega ohm, so that's good. This is B clock, the left to right clock, and then data in. Out goes into a ferrite with a little capacitance. This is just a teeny little filter. What's cool about the Maxim chips, and I love Maxim audio amps, they're so great, is they have pretty low EMI. You don't have to have a gigantic coil on the output. The speaker itself is the inductor. You have a little bit of ferrite just to keep the super high frequencies out. Anal capacitor. This does an LC filter. It just cuts out everything above a megahertz, which would never be heard anyways. But it just reduces the amount of maybe vibration that would go through the coils. Maybe they don't like it or something, or having EMI through the wires over a megahertz. Maybe it's more likely to cause you problems if you're going for compliance. And then there's a gain pin. The default, if you leave this pin floating, it's 9 dB, which is fine. So next I have my Pi 0, and I've logged into it like so. And I'm running Jesse, and I'm actually just going to follow this guide from Pimeroni. They make great guides. They're awesome, and I think they probably follow my guide sometimes. So I'm going to follow their guide because, I don't know anything about setting up these sorts of things. So they have a DAC as well. So they're like, okay, and this is kind of cool because it's a lot like my tutorials. Pseudo nano. Make sure that this is. And so, there's no blacklisting going on here, so that's fine. Let's go into Etsy modules, which. Yeah, so I will disable this. Okay, so I'm going to turn off the BCM 2835 sound. And then they're like, make an asound.conf. Cool. Let's see if this works. And then we're going to add an overlay. So for example, here, it doesn't say I need to have i2s on here, but I don't know. They see it, might as well. And then they're like, let's just use the hi-fi buried DAC device tree overlay. So the device tree overlay is going to load up that module and give me that PCM out on the PCM pins. So let's reboot. And now I'm actually going to look up the eLinux GPIOs. I love this page. Its page is so colorful. So what we're looking for is which pins. So this is each GPIO, and then these are the alts that are available. And like we talked about earlier, PWM 0 and PWM 1, those are the pins that are used for the basic audio. And then it looks like, okay, so PCM clock is available on GPIO 18. Okay. So one first thing I'm going to do is I'm going to run in my tutorial, I talk about how to check the alts, and I keep forgetting the name of the program, but I have it installed here. It is GPIO-V. Oh, right, sorry, GPIO-V is just the version, and then GPIO read all. Okay, so, ooh. Yeah, we see, oh, you know what I have to do? I have to turn off my analog audio that I did. So, because I did that to this Pi earlier. And what did I edit to do that? Okay, I'm going to turn this off because I don't want it to mess with 18 and 13. Let me, I'm going to reboot again. Oh. Yeah. I'm going to reboot again to make sure that I don't have my analog PWM outputs. I think they share the same pins as the PCM interface. You can't have both. You can have one or the other. So this way I turn off the code that I wrote earlier to have the PWM audio, and maybe we'll have the PCM audio. System D, it's booting. Do the little dance. Okay. Okay, so we're going to run GPIO read all again. Okay, so this time we have GPIO 18 on alt 0. And this is alt 0, so GPIO 18 is PCM clock. Okay, so that's good. And then what else do we have as an alt? 28 and 29 are, sorry, pins 20 and 21. PCMD in and PCMD out. So it can do actually microphone as well. We're not going to be using the microphone, but it does have the ability to do that. And then it also looks like it's using GPIO 19. So FS, I believe, well, clock is probably the B clock, right? And then FS is probably like frame select or something. So maybe that's the, whoa. No, go away. That's probably the left-right clock. Let's actually look at this on the scope. It's ready for scope cam. Can we scope cam it?
Yep.
Okay, so we're on scope cam. So let me just wire up. Nothing is hooked up yet. So let me connect ground on my little scope probe. Get a nice long wire. Connect to the scope, and then I want to probe. Okay, Tony's like, use the Sele. I'm like, no, I'm going to use my scope to look at the data. I just want to see if the data's coming out, because if the data's coming out, like, I can continue. Just probe. No, you know what? I got to remove this previous project. Okay, let's look at GPIO 18. I don't see anything on GPIO 18. That's not good. Let's look at 20. No? 21. Ooh. That's not good. I'm not actually getting audio. I wonder if I have to play. Oh, thanks, Tony. I was like, I wonder if I have to play some audio. And Tony's like, you have to play some audio. This is cool. We should have like Tony's just a floating head.
He's working on it.
Well, he's been working, yeah, because he was working on this project. He was just turning it on and off because he was like, I want to see if I can get it to work. Okay, so This time I'm going to connect to GPIO 18 and I'm going to play some audio. Oh, I did see something. Oh, wait. Channel count not available. Uh-oh. I did change this as well. This audio, I wonder if I have to... Uh-oh. Channel count not available. Well, that's pretty exciting. A play L. All right. I have like a little friend. A play L. Okay. Card 0. How do I never used A play. Really, list PCMs. It does look like I've got something, but I have to just select by name, format channels. I think I want to select by name. And then how do I do name equals device Sundar Pi Hi-Fi? Unknown PCM, maybe plug hardware? Okay, now this is like, at least it's finding something. I'm not able to parameters. I'm actually going to Google for the Hi-Fi Berry A-Play and see if I can find something. Okay, so they're like configure the drivers. We already did this. Oh my god, they have a lot. PC, A-Play L. Okay, so yeah, I find that. You guys play, it won't convert. They don't say anything about it. Well, I found a sound card. It's enabled to 5 parameters. I'm gonna ask K-Town what's up. Or not K-Town, Tony D. Yo, Tony D. Hold on. Let's see. Unable to install hardware parameters. Yeah, use device equals hardware. Okay, well then super crash. User share sounds ALSA. Oh. Nope. Channels count not available. All right, to the Googles. And we'll continue this later. Ooh, solved.
Think it'll be on the screen. The screen for that.
Yeah, I'm just gonna.
You're not gonna see up there,
I have no idea what's going on.
Okay.
They're like running as root. I don't see how that could.
I'm gonna leave you as this.
Okay, yeah, leave me to my Googles.
Screen on the right is what you are.
Yeah, Word. Okay. Cards. Back of the sound card. Okay. We can do this together. asound.conf. Start with a fresh image. Hope not. I do have a Jessie light though. I mean, it's worth it. Maybe I should just try with a I have an image of Jessie light that I burned because I was going to test it. I'm willing to try that. In Linux, like, burn a new SD card image for your Raspberry Pi is the equivalent of like turn it off and turn it back on again. Okay, so let me try this Jessie light. I don't think I messed with the audio that much in my previous project, but we'll find out. All right, we'll go through this tutorial again. I wonder if it's because I turned on i2s. I mean, it doesn't say to turn on i2s. Who knows? You can do it, System D. Why seems to take like a long time the first time you have to boot? Okay, start from beginning. I am 90% sure there's nothing in blacklist. That's correct. And the modules. Oh, interesting. This one doesn't even have anything in the modules. I wonder if that's it. Maybe there's something that. Wait. Yeah, this is new asound.conf. See how that goes. All right, I'll turn off this i2s on. Who knows? Hi-Fi Berry dash DAC. We'll do it again, and we'll keep doing it again. Not yet. I just I did the Linux equivalent of turning it off and back on again, which is starting with a new fresh SD card.
That's fine.
I probably grabbed like 25 SD cards from the SD card bin in Adafruit over the course of just like doing the PyTFT tutorial.
Yeah.
I will end it, no matter what, we'll end in like 5
Okay.
minutes.
As long as there's stuff that I can,
Yeah, you can just hang out.
I'm just gonna hang out.
I mean, this is probably not going to work because I'm doomed. All right. RPi DAC overlay. Oh yeah, now I got 2 cards. Okay. So let's try this A-play. I probably just gorked it from before with the PWM audio. Okay. Okay, so that did not, I don't believe that went out on the analog. I think they went on the digital. Sorry, I think they went on the digital, not the analog. So hardware. What was it? Colon 0, comma 0. Yeah. Yeah. No, I want card 1. Nope. 1 0. Nope. All right, I'm just gonna do what you suggest. I don't know how the hell you figured this out though. Okay, hold on. Copy. I mean, these tutorials might also not have been written for the zero. Yes, that's audio. Turn on i2s. RPi DAC overlay. Okay, let's just do the RPi DAC overlay, which is, I think, similar to the, you can look at the overlay files on like GitHub or decompile them. Did you edit the ASound conf? Through boot. I wonder if it's an ASound conf, it's not a good idea. What, then I get like this. Register card failed. Okay, I still have 2 cards. No. Hates it. Weird channel format. Yeah, I'm telling you, I don't have internet on this Pi, unfortunately. Yeah, it could be in a weird format. Although 16-bit little endian, I mean, like. Is it because it's mono? Could it be because it's mono? I hope so. Sounds. There's also some scratch audio. Is it the USB audio? Try speaker test. That worked. Okay. So it was because it was mono, not because of anything else. Because when I do speaker test, I'm definitely getting output. So can I go back to scope cam?
Yeah, let's go to
Speaker test. I mean, it's pink noise, but like, whatever. Okay. Oh, I'm back down to this old. Okay, so, oh, come on, give me 1 volt peak to peak. Okay, so natural thingy, and then if I run speaker test, you see a lot of activity. So let's zoom in. So it looks like about 3 megahertz. So that's on pin 18. Actually, I should just run speaker test because actually it just runs continuously, which is kind of nice. Oh, and I wanted the eLinux GPIOs. Okay, so you've got the PCM clock on pin 18. Let's check pin 19. See what's going on over there. Channel 2. So I'll move this down. So you can see, and then I'm going to trigger on channel 2. So yeah, you can see that the pin 19 is going up and down kind of slowly, and then you get like there's a lot of action in the middle. So that lets you know that this pin is the left-right clock because it just alternates at an even pace. And then I want GPIO 20. No, and then I want GPIO 21. Okay, so GPIO 20 is not the output I want. I want GPIO 21. And you can see well, I'm not going to be able to trigger really well on this because you can see it's shifting. But this is the data, and it's just moving in and out really, really fast. You know, as the audio changes. So that's all the bit messages. So I'm going to try wiring this up really fast. So plug in the amplifier.
Are you trying to scare bats?
Am I trying to scare bats?
Yeah, are you?
Bats are okay. I have no problem with bats.
Okay, the answer is no.
I don't. Yeah, this doesn't really relate to bats. This is not. Yeah, there's not a lot of bats going on here.
Make it clear.
Yeah, I don't completely know why that would be an issue, but okay. Okay, I'm going to wire up LR clock we determined was pin 19. Let's look at pin 19. Oh man, I just totally rebooted it. Oops. Okay, but it was 19, and then B clock is 18. And then data in was, I think, was it 21? Okay. Yeah, plugging in the 5-volt and ground kind of rebooted this. The Pi Zero does not have a very sturdy power supply. So you kind of can't hot plug stuff. So don't do what I just did. What was it? Was it speaker? Yeah, speaker test. Okay, so I think, yes, so 19 was the left-right clock. 21 was data, and then 18 is clock overall. And then I'm going to look at the output from my amplifier. So this is the output from the amp, and let me put it on 1, and then I'll trigger back on 1 again. So high frequency, 350 kilohertz, sounds about right. So let's get this speaker, get this little speaker that I'm going to connect up, see if I can hear. It's going to just sound like noise, but at least I'll know that it's working. Yeah, that's great. It's just noise. That's actually on purpose. So when I play the speaker test, and when I'm done, and I have 30 seconds left, I'm going to see if I can find a audio that's not, let's see, USB audio tutorial, I think. Yeah, it's user share scratch. A play D hardware 1,0 user share. This might also, oh, it's not. Oh, I don't have scratch. Oh, because it's light. Okay, so all I got is speaker test. I can have other modes. Can I play tones and stuff? Oh, I guess I can play tones. Great. Frequency, and then I'll play 1,000 hertz. Oh, I have to counter channels, frequency. So let's try F. That's not 1,000 hertz. Why does it say pink noise? Can I have it not do that? I wonder if I have to do over here. All right, so I just don't know how to use speaker test, but it is working. Well, that's cool. And then maybe I can use speaker test to play this. I'll try this and then we'll be done. Speaker test, rate channels and periods wave file dash W. I don't know if it's gonna work. Nope, it's still. It'll play noise, but it won't play. It'll play this like 16 octaves of pink noise because it's whatever the setting for speaker test, which is the only thing I've ever actually used it for. Is just playing noise. Oh wait, I have to do T. Okay, so you have to do that, and okay, so dash T.
Front, left, front, right, front, left, front, right,
Okay.
front, left,
Okay, thanks, lady.
left, front, right, front, left, front, right, front, left, front, right.
Okay. Anyways, we got it working in a record half an hour. And that's how long it takes to engineer something. See, it's not that hard. Just have to have Tony Nicola help you. Okay, Team Adafruit is going to sign off. I think we did pretty good. We got PCM output working on the Pi. I'm going to noodle around and get the instructions to be super solid before we're at the tutorial because, as you can tell, it's like inconsistent, like whether one thing works or not doesn't. So now that I've got it working on Jesse Lite, I'm going to kind of backtrack, edit all the files, and make it so maybe it's like the default audio. Then the breakout seems to work pretty cool. I'm going to mess with like the gain and left-right channels now that I can have speaker test working and the left and right. When she says left, right, left, front, front, right, front, left, front, right. That way I can tell which channel's working. And then I'm going to mess with the gain a little bit. And that's the breakout. It's going to be in the store in a couple weeks-ish. Yay. Thanks, Tony. Let's say thanks, Tony. Thanks, Tony. Same team. Oh, there's a cat. Whoa. He didn't like that. Okay. Front cat. Right cat. Front left cat. Front right cat. Front left cat.
That's it. Okay.
Yeah. Say goodbye.
Yeah.
Okay.